We define now the limit of the function of two variables, where the function is fxy, the variables are x and y, and we say our x is going near to a and y is going near to b. If I want to find the notation for the limit, there are two ways of writing. One way of writing is like this one, that we say the limit of the function fxy when x tends to a and y tends to b. We can write like this one. Or the second way of writing is that we can write it like this: the limit fxy, we say here x and here y going to a and b. That, as I mentioned here, x is going to a, y is going to b. We want to see, and this here is in a space xy plane. This is my x-axis, this is my y-axis, and here's my origin. I take this point as point a, b, and this here is the projection of point a, and this here is the projection of point b. Now I say my x is going towards a and y is going towards b. What's happening to my function value? To which value it is going to move? That's why, as in the last example, we say x tends to a plus y tends to b, and the value is going to L. So here we are just looking on the value, that what is going to the value. And I will show you with the help of example, that when x is going near a and y is going near b, how we get the values. I take this example, find the limit of exist. If we say if it exists, it means there are some of the cases where limit does not exist. But here we say we will find the limit if it exists. So in the above cases also, as one of you say limit exists, means left hand side, left hand limit is equal to the right hand limit. Here we say also. Now here I take the particular example that my xy is going to 2, 3. The function is x square minus 3xy plus y square. Let us see here what's happening. My x is going towards 2 and my y is going to 3. I want to find the limit of xy is going to 2, 3, and the function is here x square minus 3xy plus y square. So I just make the substitution x equal to 2. We get here 2 square minus 3 into here is xy. Here is 2 into 3 plus y square is 3 whole square. So we simplify this one. We get here 4 minus 18 plus 9. So it's here 13 minus 18. The answer is equal to minus 5. So limit exists, the value of the limit is equal to 5. I take another example, limit xy tends to 1, 0, that x equal to 1, y equal to 0. And here we having here the value of this one. We're having x over x minus y plus 1. When we take the value of this one, we can get here the result as is 1 over 1 minus 0 plus 1. So I get here result over 1 upon 2. So the limit exists and is equal to 1 upon 2. If I take another example, we're having the example that here we are having limit of the function we want to find xy, and the value of here is y over x minus y minus 1. So when I try to find the limit of this one, so I can see here we'll get here x is here is equal to going to 1, 0. This x equal to 1, y equal to 0. Here is the function value is a is 1, b is 0. If I take this value, when x equal to 1, y equal to 0, we get here 0. We get here 1 minus 0 minus 1. This is 0 over 0. So what lesson I get here? It means as above, I get x square minus y square x minus 2. So there's something which making it 0 and 0. I need simplification to find that the limit exists or limit does not exist. So that's mean I need to make some more work to get this one. So in the case, as we have seen, sometimes the limit exists, sometimes limit does not exist. So some of the cases when it's 0 upon 0, then we have to look on that one, that if the limit exists, the limit does exist. In case of one dimension, it was very easy that we are having here only one value a, and this was our x-axis. So we say x goes to a from right and x goes to a from left. They see a plus and a minus. But when we take here case of 2 dimensions and we are having here the point AB. So in this point, when we take the limit, so we can see here there are many ways to reach this one. This is the way here we are going to take x equal to a, and here we are having the line y equal to b. Here we can have the curve coming to this one. We are having the curve coming to this one. We have the curve coming to. There are infinitely numbers ways we can approach the point AB. So if we are having here, we have only 2 ways, and we say right hand limit, left hand limit, they are equal. This means we say the limit exists. But here when we want to find it, then from each way, it must have the same limit. So sometimes we say here, in these cases, we want to prove the limit does not exist. This means if we are able to find only two ways where the limit is not equal, then say limit does not exist. So the problem we are going to discuss in this section will be the limit does not exist, because limit has an infinite number of ways, and we want to check. If limit exists, obviously we can have the value of the limit. But if it's a 0 over 0 form, then we try to find the ways where the limit does not exist. So that's the example I'm going to quote you. I explained you the above picture. Here's my origin, and this is my x-axis, and this is my y-axis in a more clear way. For example, I am here the xy plane, and this is my point AB. So one way is coming along the straight lines. This line is parallel to y-axis. This line is parallel to x-axis. Here the value of x is equal to a. This line is x equal to a. And this line is x equal to y equal to b. So this is my x-axis, this is my origin, and this is my y-axis. This is case 1. The case 2 is that we can have here, this is my y-axis, that's my x-axis, as my point is AB. Now I am approaching this point from this line, and from straight line like this, I can have a line like this one. I have the line like this one. There I can have infinite number of points which are passing through the lines passing this point, and each path we say the limits, we can find the limit. This number 2. Number 3 is that we are having here the xy plane. This is my x-axis, this is my y-axis, and this point is point AB. So I can have here the curve. This is my curve passing through this one, and I have another curve. This is my another curve passing through this point. I can have a curve here which is passing to this point. I have the curve here passing to this point. There are many curves which are passing to these points, and I want to calculate the limits along all of these curves, and we say that this must be equal for the limit to exist. So there are these 3 possibilities. We can see it. The easy one is when it's for the origin, then we say x equal to 0, y equal to 0, x is equal to 0 is along y-axis, and y equal to 0. Here is x equal to, sorry for that one. This is equal to x equal to a. This one is x is equal to a, and this is the value y equal to b. So this spell is correct. That one. Here I'm going to give you the example where I'm going to take these cases, and we explain you with the help of that one. The example is show that the function, the limit of the function x square minus 3y square over x square plus y square, then the limit xy is going to 0, 0 does not exist. We want to prove this one. We say this function, we say is fxy equal to x square minus 3y square over x square plus y square is defined everywhere except the point 0, 0 is defined everywhere except the point x equal to 0, y equal to 0, the point 0, 0 is not defined. So we can't find the value of the function directly by substitution. Now if we do this one, because it becomes 0 upon 0, so we take the limit along the line. The first always we take here limit along y-axis. We take it along limit along y-axis. Limit along y-axis mean along y-axis x equal to 0. So when we want to take the limit along y-axis, say the limit of the function x equal to 0, y tends to 0, 0. So I take x equal to 0, I get here minus 3y square over y square. I simplify this one, I get here the limit x, y going to 0, 0, get here minus 3. So my limit of the function is minus 3. This is my number 1. Now I take here the second result, that I want to find the limit number 2 along x-axis. When I want to find the limit along x-axis, so obviously I'm going to take along x-axis. Along x-axis is my equation of the line y is equal to 0. When take here y equal to 0, and we define my limit, here is y is equal to 0. Now I take here the function limit x and y 0 going to 0, 0. When I take y equal to 0 here, then I get here x square over x square. X square over x square. Now simply when I simplify this one, I get here the limit x0 going to 0, 0, and that's equal to 1. The result is equal to 1. This is my number 2. So I have here the limit along y-axis is number 1, and limit along x-axis is limit number 2, and they are not equal. When they are not equal, say limit does not exist. So I take another example and want to show you if they are equal, then what happens? Then we have to take some additional path. This is my next example. My second example is I want to show that the limit xy tends to 0, 0, xy over x squared y squared does not exist. When I take this function of fx of y is equal to xy over x squared plus y squared, I can see here this is not defined at 0, 0. So it means when we want to, it's not defined at 0, 0. It means it's when we take x equals to y equals to 0 upon 0. So I want to see two paths where the limit is. So I take here number 1. I take along x-axis, as before we say along x-axis y equal to 0. So we say the limit x0 going to 0, 0. We're having here the value of y equal to 0. We get here 0 over x squared plus 0. So get the limit x0 going to 0, 0. Get here 0. The value is equal to 0. This is my result 1. The second result, I want to see it here. We take it along y-axis, So here we are having here x equal to 0. When I take here x equal to 0, I can redefine my limit 0y going to 0, 0. We're having here xy, y is 0, x is 0, then this is equal to 0 over 0 plus y squared. So I again get here limit 0y going to 0, 0 is equal to 0 is equal to 0. This is my number 2. So it's very interesting to see that here the limit x tends along y-axis is 0, along x is 0. Which means I have to take one more seat here. I try to find the limit along the line y equal to x. So I see what's the limit of, because I can take along y equal to x, like y equal to minus x. I can take the limit along the curve y equal to x squared, y equal to x cubed. I have many possibilities to do that one. So first I use y equal to x. So here when I take y equal to x, then I'm having here the limit xx going to 0, 0. We get here x into x over x squared plus x squared. So I can just find here the limit xx going to 0, 0. I get here x squared over 2x squared. Simplify this one. I get here limit xx going to 0, 0, 1 by 2, and this is equal to 1 by 2, and this is my result number 3. So I can see here, here is my result 1, it's my result 2, they are equal, but here result 3 is not equal. So I say this implies the limit xy over x squared plus y squared when limit xy tends to 0, 0 does not exist. So here we are having a third limit we have to find to see that the limit does not exist. I give you some more examples to give you more idea about that one. We take another example. We want to find the limit of the function y x cubed over y and over x6 plus y squared. The limit is xy going to 0, 0. We want to show that it does not exist. Again, we can see this function is not defined at 0, 0. So, but we want to find the limit. So, we can find the limit even the function is defined at that point. Again, we take the limit about x equal to 0 along y-axis, y equal to 0 on x-axis, then the y equal to x. And if we see the result, if they are all equal, then we need some other path to find the limit. So, number 1, as before, we are going to check here the limit about along y-axis. And as I mentioned here, x is equal to 0, and we can have here the limit x equal to 0, 0 y going to 0, 0. We get here x equal to 0, this is 0, x equal to 0 plus y squared. So this is the limit xy 0y going to 0, 0 of 0 is equal to 0. This is my result 1. So number 2, I take the limit of this one along x-axis. When I want to define the limit along x-axis, this means my y equal to 0. When I take y equal to 0, I have the limit x0 going to 0, 0. Now y equal to 0, this again equal to 0 over x to power 6 plus 0. So result of this one, limit x0 going to 0, 0, going to 0, 0 of 0 is equal to 0. This is my result 2. Now result 3, they are equal, so we take along the line. So we say we take the line y equal to x. So I just redefine my limit. I have here xx going to 0, 0. I have here x, and we are having here x to power 3 and y. So here is x to power 3 into y is x to power 6 plus x to power 2. So that will give me here the limit of this one. I have limit xx going to 0, 0. I'm having x to power 4 over x to power 6 plus x to power 2. We take x to power 2 common, and we can have the limit xx going to 0, 0. I get here x square over x to power 4 plus 1. We take the limit of this one. When x is 0, this is 0 plus 0 plus 1. That's equal to 0. Again, this is equal to 0. This is number 3. So it's mean there are, when along x equal to 0, y equal to 0, y equal to x, the limits are same. So here we take another path. We say we take here this equal to y equal to x to power 3. We take along y equal to x to power 3. We substitute it. We can redefine this one. We have limit x and x to power 3 going to 0, 0. We get here x to power 3 into x to power 3 over x to power 6 plus x to power 6. So this will give me here the limit x to power 3 going to 0, 0. And here we get here x to power 6 over 2 x to power 6. We simplify this one. We'll get here is equal to limit x to power 3 going to 0, 0 is 1 upon 2. Result is 1 upon 2. This is my number 4. Now I can see here limit x tends to 0 along y-axis is equal to limit along x-axis is equal to limit along the line y equal to x, but it's not equal to limit along y equal to x cube. This means if one of the limit we find here not equal, so they are not, 1 is not equal to 4, 2 is not equal to 4, and 3 is not equal to 4. We say this implies the limit x y tends to 0, 0, x cube y over x to power 6 plus y square does not exist. In this reference, you can find some more example in my notes, and you can just see in the description the reference for that one. Also, the previous videos you can find also the reference for that. We have the video for the whole calculus 3 was for the vectors and vector value function, and now we are doing the partial derivatives. You find it there. Also, some example you find there. And also you can go any of the book of the calculus, and this 11, chapter 11 or chapter 12 there. There are many other examples, many exercises. So I will mention if you want to learn mathematics, you have to do a lot of exercises. So we are having always some good, nice points, some tricky points in our problems, and you have to find that trick and you have to solve that one. Our next topic is continuity of a function of two variables. And we have the definition like we have the one dimensions. As I mentioned, I explained you before. Here the function fxy is continuous at the point a, b, because in two dimensions we have the point, and we have the limit of the function fxy at the point a, b is equal to f of a, b is the value of the function. So we get the three things. Number one, the function is defined. That's why we get the value of the function. Number two, we can find the limit, and limit is equal to value of the function. So when these three things are while we see the function is continuous at the point a, b. I take an example I want to show you. That show that the function fxy, xy over x square plus y square rational function is continuous at the point 1, 1. We check it. We have to take the number one, the function is defined. We say we find the value of the function at point a, b. If it's defined, we can get the value. We have 1 into 1 over 1 square plus 1 square is equal to 1 over 2 is 1 over 2 is my result 1. Now this line means the limit, the function is defined and the value of the function is 1 by 2. Number 2, we find the limit. Find the limit. We are having the limit of the function xy at point 1, 1, and we are having here xy over x square plus y square. So get here 1 into 1 over 1 plus 1 is equal to 1 over 2. We have the limit here, limit xy going to 1, 1. So this is 1 upon 2, this is my number 2. So we can see it here that number 1 is equal to number 2. What's mean? That's mean the limit of the function xy at the point 1, 1 of the function xy over x squared plus y squared is equal to value of the function at point 1, 1. This implies that the function fxy is equal to xy over x squared plus y squared is continuous at point 1, 1. So that's the idea. We take as a note here, if we take here the point, let our point be 0, 0. We check here the same function, is this continuous point 0, 0. I want to find the value of the function at point 0, 0. This is 0 over 0. This implies the function is not defined at the point 0, 0. This implies the function is not continuous. So there's a continuity with reference to the point. It's continuous at 1, 1, but it is not continuous at point 0, 0. So we have to find number 1, this point must be in the domain. Number 2, we can find the value of the function because in the domain we can find the value, and the limit is equal to the value. Why the limit must exist? If the limit does not exist, mean the function is not continuous.